Topic under discussion is pamaquine and primaquine. What is the medicinal of the pamaquine and primaquine? We'll talk about the medicinal of pamaquine and primaquine in today's discussion. I'm discussing both the drugs in one lecture. The reason behind is both are having same structure and a little bit different mechanism of action. Yeah, there's a slight difference in structure also. Okay, so before commencing the lecture, what will we discuss regarding pamaquine and primaquine's medicinal? Let me tell you guys those points that are going to be discussed in today's discussion. We'll talk about the class from where these drugs are. Then we'll talk about the structure, IUPAC, SAR, mechanism of action, therapeutic uses, and synthesis. Got? Very simple. Yeah. Yes, very simple. So let's start this simple discussion from the pamaquine first of all. Pamaquine is actually one of the anti-malarials, and it is actually belonging from the 8-aminoquinolones. Now, what is this 8-aminoquinolones? Very simple. 8-aminoquinolone. Quinolones on the 8th position, they are having substitution. Now, this is quinolone. I hope it's visible. This is quinolone. And on its 8th position, if there is a amino group, then this is called as 8-aminoquinolone. Now this is amino on 8th position. How like 1, 2, 3, 4, 5, 6, 7, 8. On 8th position there is substitution. That is actually amino. So this is called as 8-aminoquinolone. So both the pamaquine and primaquine are actually the 8-aminoquinolones from the 8-aminoquinolones. Okay. So this is the main parent ring must be there in their structure. Then there will be a kind of modification available within this structure. Then the names will be given to those structures. So if this structure is seen, so then along with that, on this amino there is this attachment available, this kind of attachment available, then this is actually named as pamaquine. Don't feel confused. I'm going to explain this further while I'm going through the structure. In short, what is the pamaquine and primaquine? These are actually the derivatives of the 8-aminoquinolones. Means in these two drugs, when you are studying the structure of these two drugs, you will find this kind of ring mechanism. Means this kind of ring must be there. So here is the ring, number 1, number 2, and along with that there is nitrogen. So this is must here. If this is must, then means that these two are actually from the 8-aminoquinolones. So in short, these two belong to this class. That is 8-aminoquinolones. Hope you got this understanding. This is the 8-aminoquinolones. Now let's come towards the interesting part. That is the structures of the pamaquine and primaquine. First of all, let's discuss the pamaquine. Now, here I will just tell you people about the trick. Through that trick, then you will become able to write in a very easy way the structure of the pamaquine. Now, what is that trick? Very simple. First of all, I will give you this drug the name. That is actually the trick name. I must give you guys the understandings. That is regarding trick name. So this is the pamaquine. Now pamaquine, I must memorize this pamaquine by mean of a trick name. Then from that trick name, I will be able to draw the structure. So now what is that trick name that I have given to the pamaquine? That is actually the pamaquine dep-methoxy. Pamaquine dep-methoxy. This is now the trick name that I've given. Suppose I'm asked in exam, write down the structure of pamaquine or draw the structure of pamaquine. So how will I draw? Guess what? Simple. I have learned the pamaquine by this name, which is the trick name. Pamaquine dep-methoxy. This is the trick name that I've given to this drug. Okay. So now by means of this trick name, I will draw the structure in a very easy way. Looking to this trick name, I will draw it now. Just concentrate. So pamaquine dep-methoxy is the trick name that I've given. First of all, let me tell you people about this trick name. Then I will go through the drawing. Pamaquine, we know. This is actually 8-aminoquinolones. And DEP stands for diethylamino-pentane. Let me draw it here. Diethylamino-pentane. You are supposed to draw this kind of structure. 1, 2, 3, 4, 5. Pentane, we know about pentane. So when we just get this kind of arrangement, 1, 2, 3, 4, 5 carbons in chain, and with that, if we attach nitrogen, and with that we attach C2H5, diethyl amino pentane. So this must be remembered from this DEP. Okay, DEP stands for diethylaminopentane. So now this is the name. Methoxy, methoxy is having is actually a carbon having methyl having oxygen. Methoxy. Okay. So now this is actually the trick name. From this trick name, now I will draw the pamaquine. Just concentrate. What I need right now is your concentration. Simple. Pamaquine. We know what is pamaquine. Now for this name, I'm drawing the structure of the pamaquine. Pamaquine is actually what? 8-aminoquinoline. So now first let me draw the 8-aminoquinoline because I know that pamaquine is 8-aminoquinoline derivative. So here we got the structure of the quinoline, and here is on 8th position we have substitution having nitrogen with two hydrogens, and then we have DEP. Now this DEP will be actually attached with this nitrogen. This hydrogen will be substituted with the DEP. What was DEP? Diethylamminopentane. Now how to draw it? Simple. Stretch the bond here. Carbon, carbon. 1, 2, 3, 4, and 5. Then stretch the bond with nitrogen. Then with that attach C2, H5, and another C2H5. So this is DEP now. Diethylamminopentane, like this. Got? So now here is DEP with the pamaquine. Remaining is methoxy. Remember, regarding 8-aminoquinolines, your quinoline ring, this quinoline ring must be having substitutions on two positions. One substitution will be on the 6th position, another will be on the 8th position. So two positions are allowed for the substitutions regarding pamaquine. Okay, regarding 8-aminoquinolines. So here in the 8-aminoquinolines we got one position that is actually occupied, another is the 8th position remaining. So 1, 2, 3, 4, 5, 6, 7, 8. 8th is actually occupied, 6th is remaining. So here is the 6th position. With that we will attach methoxy. So like this we got the structure of the pamaquine. Methoxy, quinoline, amino, DEP. Methoxy, quinoline, amino, DEP. This is actually the trick name that I've given. So by means of this trick name, I just got the entire structure in a very easy way. I hope you got the trick name and the entire process. So from this lecture, you have got two tracks. Number one, the trick name. Number two, the way to get a trick for a particular structure. So you can have your own trick, or you can use my trick to memorize and to draw the structure of the any drug or of the pamaquine by this way. So that's it, simple. So I gave you guys the trick, the way to take a trick, and the trick actually. I gave you two good things. One trick, another is actually the way to take the trick from any medicine or any drug while going through the structures. Well, so here we got what? Pamaquine, its structure, its trick name. And primaquine is just easy. How? Like very simple. Just erase the C2H5 and put here hydrogen and hydrogen. So we just you can say replaced ethyl with the hydrogen. So here we got two hydrogens. So like this, if this is the structure, then it is named as what? It is named as primaquine. If there is ethyl, then it is pamaquine. So this is pamaquine, this is primaquine. And one another identification, another shortcut identification is that pamaquine, primaquine both start with P and their structure is also like P. P. And another identification point. Hope you got this trick. Well, now let's come towards the mechanism of action. Before moving towards the mechanism of action, let me revise this for you guys in short. Pamaquine is one of the antimalarials, which is actually from the 8-aminoquinolines, and 8-aminoquinolines are actually the quinolines having substitution on the 8th position. That is actually amino. So if amino is available, quinoline having amino attached is called as actually 8-aminoquinoline. So pamaquine is actually the 8-aminoquinoline having this substitution on the amino as well. So this is actually the DEP substitution. That is actually called as diethyl aminopentane substitution. Remember, this is the name that I've given to this particular portion. While in IUPAC, this will not be the name given. That is actually in the trick. So the trick name is different. The IUPAC name is different. Okay. So for now, Just for the trick name, I just gave you guys this name. Then we got what? Then we got a trick name for this pamaquine. That trick name was pamaquine depmethoxy. So I have memorized pamaquine, not just pamaquine. I have memorized this pamaquine by the trick name, that is pamaquine depmethoxy. Now from this trick name, I just actually go through drawing of the pamaquine structure. So pamaquine, I know it is actually 8 amino quinoline. Dep is this, and methoxy is this. So we got the entire structure. Then if we have HH here, it is primaquine with this nitrogen, and if we have C2H5 with the nitrogen, then this becomes pamaquine. So just difference is in the H and C2H5, ethyl and hydrogen. So if ethyl is replaced with a hydrogen, that is primaquine. If there is ethyl, this is now pamaquine. This is for the pamaquine A, and this is for the primaquine. So hope you got the structures and the tricks. Now let's come towards the mechanism of action. Very simple. Regarding pamaquine, it is believed that it is acting on two spots. First, let me give you guys the idea of parasite. That is actually malarial parasite. What? Malarial parasite. Let me give you the idea of this parasite first of all, because before, if you don't have the idea, then you are not able to get the understandings of the mechanism. So let me give you short brief idea regarding the life cycle of malarial parasite. So first of all, when it is in the anopheles, so this is actually anopheles, remember, wings of the anopheles. We cannot call this wings. Anyway, coming to the point, there we have sporozoites in the anopheles. These are injected into the blood of the humans. So when these are injected, they travel to the liver. There, these sporozoites are called as schizones. Now, these schizones will modify, will change their shapes. They will become merozoites. Then they will travel to the blood, where they will form tropozoites. Then those tropozoites will be converted into gametes. And again, those gametes, if are taken back by another enophily, then that will become sporozoite back. So this is the cycle, okay? In shortcut cycle. If you want the detailed explanations, we have explained this in our another lecture. Just go for the lecture name, that is anti-malarial drugs by Dr. UUT, or simple, if you want the life cycle, just write in YouTube search bar that the doctor huge lectures regarding anti-malarial, simple anti-malarial or malarial life cycle by Dr. UUT. Anyways, you can write anyway, so you will get the structure. Sorry, the video. Coming to the point, I'm becoming tired because of excessive lectures and busy schedules. Sorry for the ups and downs during the lectures. Well, coming to the point, mechanism of action. So now if we indicate pamaquine, what will it do? Simple. Pamaquine will come and we will target two portions. Number one in the liver, number two in the blood. In the liver, it will have its interaction with the schizont, and in the blood, it will interact with the gametes. So the gametes and schizonts are actually the sites on which the pamaquine will actually act, and will actually interact with them, with the gametes and with the schizonts. So if it interacts, what will happen? The life cycle will be actually stopped. So like this, we will become a kind able to subside the malaria. Or we can say we can take ourselves to a right position. We can take treatment. Quite able treatment can be observed. In short, so what pamaquine is doing, simple. It is actually acting on the schizonts and on the gametes. So these two are destroyed. If these are destroyed, the life cycle is not completed. If it is not completed, so in short, we can easily take ourselves out from the malaria. So the patient will become okay. So then we have the primaquine. Primaquine is actually having a little bit different mechanism of action. That is actually, they are actually acting on the DNA of the parasite. And according to some texts, it is actually producing reactive oxygen species, which are again responsible to damage the parasite. So in short, these parasites are damaged by mean of reactive oxygen species, by mean of the interacting into its DNA with the DNF parasite, and pamaquine is actually interacting with the schizonts and gametes. So in short, these two medications are actually inhibiting the malarial life cycle by different ways. These are primaquine, it is actually producing reactive oxygen species or destroying the DNA, and pamaquine is actually destroying the gametes and the schizonts in the liver, and this was in the blood. Okay, so I hope you got this mechanism of action. If still you have confusion, drop in the comment box. Okay. So regarding structure, IUPAC, SAR, therapeutic uses, and synthesis, you guys are supposed to drop a message on this number +92 340 80 60081, and you guys will ask for the remaining topic here. I will tell you guys the way that how you will get the remaining topic. So for the remaining topic, go through this number. Drop a WhatsApp here. Thank you for watching.